So this really sucks. I created this video and somehow my mic got turned off, and I guess I have to do a voiceover for this whole thing now. I thought it was longer, but looks like it's only 18 minutes long. So history of this phone is that it was dropped, and now it's boot looping. So I powered it on, and sure enough, the Apple logo comes up with a white background since it's a rose gold phone, and um, what was I saying? So sure enough, and it was just stuck on that screen, and then it would just boot loop over and over again. So I opened it up, and it looked great inside. There didn't really seem to be any major damage. I couldn't see anything. And the first thing I always do is I plug it into the ammeter and see what it's doing. And in this case, it was going up to like zero point 0.4 to zero point 0.7 to 0.18 back to 0, and it would just keep doing that on the ammeter. I think. Is that what it was doing? Might have been another phone. Anyways, I'm all clustered today because I'm all messed up today because it's Friday and I'm ready to go home. Anyways, so these are the worst things to try to figure out. I mean, they end up just taking the longest, and with boot loop, man, it's just it really sucks, you know. Really sucks. But I feel like I'm getting a lot better, and I think if you watch this video, you'll see some of the techniques that I use to get better at diagnosing and troubleshooting these things. Okay, so boot loop, plug it into ammeter, see what it's drawn, and then you can also use your DC power supply. That's going to tell you several things. One is whether there's a VCC VDD main short or not, or VCC main, whatever phone it is. If there's a main power line short, VCC main, then on your DC power supply, it's going to show a full 2 amps or whatever you set it at. Okay, so that's an easy way to do it. Another way of doing it, which I think I might have shown some of the video. I'm doing a voiceover now, but what you can also do is measure the anode pin on the backlight. So if you know where that anode pin is, measure that in diode mode. If you get 0.2, I think I'm doing it right now. You get 0.2, so that's the anode pin right there. If you get 0.2, right, then you know you have a short on VCC main. Okay, why 0.2? Because there's a backlight diode in that line, which is supposed to be powered by VCC main, but since that is short, your power goes from that pin directly through the diode to ground, basically. So that's why you have a 0.2 drop. Okay, so that's an easy way of doing it. That's the lazy man's way of doing it. Yeah, that's probably the easiest way of detecting a VCC main short. No shields to desolder or anything like that. So I determined that there was no VCC main short. The next thing I do is, since the phone's boot looping, a few things already come to mind. One is, you always try a known good battery and a known good charge port. So that didn't yield anything. Next thing is I just measure the 3 NAND power lines in diode mode. So here's one pp0v9, pp3v0, and pp1v8. Okay, so I measured those, and the one that came back bad was pp1v8. That was actually, it wasn't fully shorted. It was at 0.03 volts. Okay, so it was a partial short on pp1v8. And in my experience, when there's a partial short in a line, it's not actually that line's at fault. It's actually a subline within that main power line. So there are main power lines within the iPhone, a 1v8 line, 3.0 line, and then you have VCC main, which runs at somewhere between 3.8 and 4.2, depending on whether it's powered by the battery or the USB cable. Okay, in this instance, it was pp1v8 that was shorted, partially shorted. Okay, so I forgot to say that yes, you always do a visual inspection before you do it. After you plug in an ammeter and a DC power supply, always do a visual inspection, which means removing all the electromagnetic tape and the top shield, and just do a visual inspection. And what you're looking for is a blown capacitor, because capacitors are the most often at fault. So just look for a blown capacitor, and blown capacitor, you can see it sometimes it's a little bit browner than other ones. Okay, so let's go back to this pp1v8 short, partial short. Okay, so if you look at all the if you look at everything in red here, those are all the components in pp1v8, and so this is, generally speaking, it's a pretty daunting task to try to figure out this problem, especially when it's a partial short. Okay, one method that you can use is use freeze spray and inject 1.8 volts into the line, and I think you can probably go up to maybe 3 amps, even though it's probably not going to even draw 3 amps. I think in my instance it was only drawing 0.7 amps. Sorry, it was was it 0.7? Yes, 0.7 amps. So basically it shouldn't be drawing any amps with the phone powered off, and it's only gonna draw amps when there's a short. All right. So I used freeze spray initially. Sprayed these 5 main, and it's usually big capacitors that are at fault. So that's why you see some of these capacitors up here missing. There's only 5 of them. I used freeze spray. There was no heat on any of those 5 capacitors. So I was like, you know what? I'm just going to go ahead and remove all 5 of these capacitors because that's easy enough to do. So I removed them all, and sure enough, the short was still there, 0.03 volts in diode mode. So then I started thinking, okay, it's got to be a sub power line. And in order to test all the sub power lines, what you have to do is okay, so pp1v8 powers more than just everything associated with pp1v8. Like for the instance, the NAND, that takes power directly from pp1v8. However, I don't know if I'm going to go to it here or not, but maybe I will, maybe I won't. We shall see in a little bit. I think I'm trying to go to it. So these power lines are, you have to look at all the filters which connect the sub power lines. Okay, so, and then there's also resistors also that that play a part in these power lines, and they just increase the voltage or decrease the voltage based on the type of resistor it is. And all these I2C lines that you hear about, they're powered by the 1v8 power line. Okay, now I'm getting to the filter part. Okay, so you see this filter right here. So on one side, the red side is pp1v8. Now on the other side of that, you'll see an I2C line. So if I click on this, am I going to click on it? Click, click, click. At some point I'm going to click on one of these, I think. It's kind of weird doing it over a narration. Trying to figure out what I'm doing here. So okay, these are resistors here, okay, and resistors rarely ever go bad. Usually what happens is that you have a cold joint or it's broken, okay, but in terms of the actual resistance, they rarely ever go bad. So you don't really need to measure the resistor, the value of the resistor. You really just want to measure the other side of the resistor to make sure that it's not shorted on one side. And for most of these resistors on the 1v8 line, you're going to get somewhere around 0.45 volts to 0.47 volts, right around there. Sometimes you get 0.36. So what I'm doing here is that I literally measured the other side of every resistor. The other side meaning the other side not red. So I measured every single one of these resistors, and everything checked out fine except for one, and this was our problem. So going all the way down to next to the NAND, I measured this side and it was 0, shorted to ground. So boom, we had our problem. So we know that it's not the resistor that's at fault, but it's something pulling down that 1v8 line, and And what is it usually? It's usually a capacitor. And is it a bigger capacitor or a smaller capacitor? Usually a bigger capacitor. So if you look at this line, there's only two capacitors connected to this line, and only one big capacitor. So sure enough, I took this big capacitor off, measured it in diode mode, and it was shorted. It was shorted to ground. Or I mean, the capacitor was shorted. So after I removed this capacitor, I measured diode mode on pp1v8 again, and it measured fine. I think it was something like 0.35 or something like that. So that was our problem. I'm going to show you where the problem is now. So I removed that capacitor, and all was good. So now I think I'm going to try to do a restore now, and yeah, I'm going to do a restore now. I don't think I showed that I put this capacitor back. But as you can see, one side of the capacitor is actually not grounded. Actually, it is grounded, but it's not part of the common ground. It's like a NAND, AGND. I don't know what the hell that means, but some sort of ground that's not common. That's not connected to the other grounded areas. All right, but anyways, I put this capacitor back, and I'm gonna do a restore. So I'm gonna fast forward a little bit, I think. All right, I don't know where I'm at, but I put everything back together, and I'm gonna put it in the DFU mode. And before it wasn't going into DFU mode for some reason. It just was not going into DFU mode. I could not get in DFU mode. But so now I'm gonna try to put it in DFU mode and do a restore. I don't even know where I'm at right now, but let's see if I can fast forward here. Can I fast forward? No, can't fast forward. I need to get out of here, man. Um, so I started up, and it's still boot looping, I think. Yes, it's still boot looping, so nothing has really changed, okay? Except for the fact that I can put it into DFU mode now. So let me watch this goal real quick. Liverpool, nice. All right, so I'm putting it in DFU mode now, and it's going to go into DFU mode. I might kind of hurry this up because I want to get out of here. But so it goes in DFU mode. I tried to update first, and I ended up getting error 2002, and I think it probably would have worked if I would have just maybe it might have worked if I updated again. Actually, you know what? It wouldn't have worked because there was actually a. You'll see later in the video that I replaced this. I accidentally moved the resistor when I was taking out one of the caps for the pp1v8. I'll try to skip to it real quick, and then it might be silenced for a good while, but you'll see. So this is the resistor I accidentally jacked up. I moved it. I started testing it in diode mode, and one side I was getting like, I think the outside I was getting like 1 point something volts, and then inside I was getting, I don't know, but I know that it wasn't the correct value because I checked the known good board, and it was zero point 0.3 on the outside and 0.47 on the inside. So I ended up just taking this 2.2K resistor and throwing it away and putting a brand new one on, and I finally was able to get 0.3 on the outside and 0.47 on the inside. So ultimately, I think this was actually um, a secondary problem unrelated to the initial pp1v8 short problem, boot loop problem. But if you notice that this is actually an I2C line, which would make sense, even though the symptoms were exactly the same. So I ended up replacing this resistor and got good diode mode readings, and the phone finally restored back to good. And the touch doesn't work on this screen for some reason. I think I have a bad screen, but the haptic works fine. So I ended up, I don't think I show it in the video here, but I ended up putting another screen on it, and all was good. Touch worked and everything, and haptic worked. So I'm heading out of here, so I'm not going to finish this up today, but I'm going to finish this up Monday, whatever. And so hopefully, oh man, this is kind of sucked. I had to redo the voice on this, but hopefully you get a better idea of how to troubleshoot these phones. That boot loop, I mean, boot loop is probably my worst nightmare, because it could be anything, But I think if you start with the known main power lines, and then you work your way towards the I2C lines, I think you'll find probably you'll find your answer probably about 80-90% of the time, I think. So that's the way I approach it, and it's worked pretty well. I'm learning a lot more about things, and so yep, hopefully that gives you an idea. And I guess, I don't know, maybe just stay tuned. If you want to learn more about it, we have an online course. Go to microsoldering.com. You'll see the promo video. I'm not going to babble anymore about it. So thanks for watching. Have a good weekend. Merry Christmas. Thanks for watching. Thank you for watching this YouTube video. I'm guessing that you stumbled upon our YouTube channel because, one, you messed up someone's device and you're trying to learn how to fix it. Two, you're a repair shop that maybe you're sending stuff out right now and you want to capitalize on repairing these things yourself. Or three, you're just a hobbyist looking to learn how to do this thing because it's interesting to you. And I just want to say that this is pretty much how I started this thing. I was repairing screens at one point, and I broke someone's device, and this was back in 2016, and I had to fix it. And there was nobody really doing this at that time, and I didn't really want to pay anybody how to do it, so I went to YouTube, just like you, and watched some videos, and here we are 2 years later, I think it's almost 3 years later, and here we are. I am the owner and operator of Microsoldering.com, and I just want to talk to you guys a little bit about this course that we have. It's on Udemy. We're selling it on Udemy for $150. It is a full curriculum, and as you can see, we got pretty good ratings. It's 4 hours of content, and it goes over everything from just the basic building blocks of a logic board to how to repair the 3 most common problems: touch, charge, backlight. And then it tells you how to set up. We have a bonus section here. It tells you how to use diode mode, how to set up your tools and equipment, and then we go into data recovery. And we're going to be adding more stuff to it over the next few months here, and it's going to be great. And we're going to launch a new website and all that stuff. So it's on Udemy for $150. We have it. If you go through our website, microsoldering.com, you can get $50 off. Just go to microsoldering.com, click on store, and then click on the full curriculum, and you'll get it for $99.99. Okay, so if you're like me and you want to learn how to do this stuff, this is probably the best way to do it from the comfort of your own desk, and you can do it today. And you'll have lifetime access, and you'll get a certificate of completion from Udemy after you're done. So, and if you have any questions, just go to the forum here and you can post a question, and I will personally answer every question that you have. Thank you for watching.